Now initial value theorem. So this was asked in exam for 5 marks. So state and prove initial value theorem. First we write down the statement. If x of t, its Laplace transform is x of s, then initial value of x of t is given as initial value limit t tends to equal to limit s tends to infinity s into x of s. Now we have to see the proof. So the differentiation property of, write down the differentiation property of unilateral Laplace transform is d by dt of x of t. Its Laplace is s into xs minus x of So now here x of is initial condition, that is initial value of x of t. So taking the limits, right here, taking the limits as it tends to infinity, both sides we get limit s tends to infinity Laplace of d by dt of x of t, which is equal to limit s tends to infinity s xs minus x of 0. So using the definition of Laplace transform, using the definition of Laplace transform, LHS or we give the equation numbers here. This is equation number 1, this is 2. Okay, so the LHS of equation 2 can be given as, we can write here limit s tends to infinity Laplace of d by dt of x of t limit s tends to infinity d by dt of e raised to minus st dt. But limit s tends to infinity e raised to minus st equal to 0. So the LHS of equation 2 is 0. So we write here 0 is equal to limit s tends to infinity s of xs minus s of 0. Therefore 0 is equal to sxs minus this is equation number 3. Okay, now but in the second term of this equation s term is not present, means here s term is absent, so we can neglect this integration. So equation becomes 0 is equal to limit s tends to infinity s xs minus, so we just neglect this term as s is absent here. Therefore x of, so limit s tends to infinity s into x of s. Now here x of 0 minus is value of xt, which value just before t is equal to 0, and this is what it is, value of xt just after t is equal to 0. But if signal is continuous, then x of 0 minus is equal to x of plus. Therefore x of 0 plus, it is limit s tends to infinity s into x of s. So in this way we can prove the initial value theorem. Next we will see final value theorem. So next is final value theorem. So it is also asked in exam. First we write down the statement for this. So if x of t its Laplace transform is xs, then limit t tends to infinity x of t is equal to limit s tends to 0 s into x of s. Okay, now we write down the proof for this. So differentiation property of unilateral Laplace transform gives Laplace of d by dt of xt is equal to sx of s minus x of 0 minus. Here also we will give continue equation number. In the previous that is in initial value we give equation number 3, here it is 4. So taking the limits of both sides as s tends to infinity, so limit s tends to infinity Laplace of d by dt of xt, so limit s tends to infinity sxs minus x of 0. So we can write this equation limit s tends to 0 s xs minus limit equation number 5. So here also in the second term it does not contain s, so we can neglect the limit for the second term at the RHS. So we can write limit s tends to 0 Laplace of d by dt of xt is equal to limit s tends to 0 sxs minus x of 0 minus. This is equation number 6. So using the definition of, right here, using definition of unilateral Laplace transform, the of term LHS term of equation 6, it can be expressed as limit s tends to 0 Laplace of d by dt of x of t. So it is equal to limit s tends to 0 to infinity d by dt of x of t e raised to minus st dt. So we can write here, but limit s tends to 0 to minus st, it is equal to 1. Therefore s tends to 0 Laplace of d by dt is we can write this as x of t 0 infinity, so x of infinity minus x of 0. Now here the term x of infinity, it can be written as limit t tends to infinity x of t. So we can write here limit s tends to 0 Laplace of d by dt of xt is equal to, we can write here limit t tends to infinity x of infinity becomes x of t minus x of, this is equation number 7. So we put equation 6 in equation 7, so we get limit s tends to 0 sxs minus x of 0 minus, so limit tends to infinity x of t minus x of 0. Therefore it becomes x of t is equal to limit tends to 0 s into x of, so we can write this as x of infinity. We replace here x of infinity by this term. Now we replace this term by x of infinity is equal to limit s tends to 0 s into x of s. Hence this theorem is proved. So in this way we can do final value theorem and initial value theorem.